Okay, this is the video that I promised everybody in Business 1123A and 23B. Today, with this shortened schedule because of the bad weather, I felt it was probably best for me to go ahead and live stream lecture there and then and cover the conceptual material, and then this afternoon to go ahead and create a video where we go through the case, and then I'll post it in both in the announcements for 1123A and 1123B. So I didn't save or record those class sessions, so if you weren't there, you missed them. But I'm going to cover you missed the conceptual material. If you want to see that, there is a PowerPoint. You can go over to the welcome module, and then you can go to the supplemental website and go there, and you can do a search in the little search box, XY, okay? And it's the XY paradigm, and it's a short PowerPoint, but it will explain to you about the XY paradigm, the linear trend. Now, in addition, okay, we are, as I've said before, we're working ahead in these cases. So we're working down in case number 9, all right? And I'll scroll down here, I'll find it for you. Let me just close this off for a moment. And let me say this, in terms of what's in the PowerPoint, estimating straight line relationships, chapter 53, okay? And that's what you ought to be reading and taking a look at. And they'll also walk you through how to use the trend line. And we're going to do the same thing in the case. And here's the case, and I'll explain what's going on there. And then we'll do the plots, and we'll talk about that. Okay? All righty. So that's the readings you'll want to look at. Now, let me go down to the file that has the resources. This is the resources for the Microsoft Excel files. And we're studying quality assurance and regression analysis. And the practical case that I had that we're going to explore is Karma Digital. And this is one of my old cases. It's XLX9 in the files section in Canvas. And then there is a cost estimate, XLS, and that's over in the Chapter 53 practice files. Now, the Chapter 53 practice files are in the Excel companion zip file number 2. All right? So we'll look at those. Now, I'm going to go back again because to make sure that you understand what's happening. We'll go down to module 10. Okay. As I said before, we're working ahead. And we're working on XLS case 10. And, pardon me, XLS 9, Earth domain, I'm sorry. We're working on 9. And for 9, you can upload, it's this copy of the XLS 9 cost estimate. It has the words key. You can upload that. You could upload the XLS 9 example. Either one of those would be fine. Now, for XLS8, you can upload this Action Plastics example or the copy of the if statement XLS8 key. All right. Now let's talk about what we're going to be doing with. We're going to work with the linear. We're going to look with linear analysis using linear regression. Now I'm going to open up. I have an Excel file down here open already that this might has the resources listed. And when you go to work on regression, you may have to add it in. You may have to add in the statistical tool pack to your machine. Okay. Now, if you notice over here, far right, and I'm going to go ahead. Let me see. I'm going to annotate this. And I think I want to do it with. Let me use the spotlight here. There we go. Okay, and let me get this out of the way. You'll see over here in the analysis, you'll see a data analysis. And I'm going to click on that, data analysis tools. And this is the statistical pack or the data analysis add-on in Excel, just like Solver is an add-on. And it has descriptive statistics, exponential smoothing, all kinds of tools. And it also has the regression tool. Okay? Now, the textbook walks you through that process and talks about finding the trend curve, how to add in format, time fill, etc. So I'm going to start though with the case, the old case that I worked with, and this is the company Karma Digital, and let me see if this is the one. And I'm going to download this. Okay. And I'll open it. I'll close that resources file. And here's Karma Digital Q. Let's talk about it a little bit. As usual, here's what we have in terms of the elements of a good spreadsheet. First, here is a description of the spreadsheet, okay? Then the file name, the author name, etc. Now, we start this time, and we're looking at a company. They make digital chips or something like this. And so what we're trying to do is examine the relationship between production volume and product defects over time. And we want to find out if, and once we look at that, if we find that there's a relationship, then we're going to have to do something about it. So this also involves quality control, because we want to see how closely production volume is related to percent defective. And percent defective, of course, can be translated into raw data. Okay, so we start here with these DVDs. These folks, I'm sorry, I said they made chips. They make DVDs. All right, and then we come down to row 9, and we've got this chart that shows the year, how much was produced, and then you're going to see a column called actual percent defective, and then you're going to see a column called regression line, predicted defective percent. So we're going to use linear trend analysis regression to forecast the amount to forecast the percentage of product that will be defective. Now I'm going to click right in here, okay, and I'm in cell D10, and as you can see, I've used the name manager. All right, and let's talk about that for just a moment. As I click in, here's in the formulas, and I'll click the name manager, and I have a name manager. It's called the intercept, and then I have production volume and where they're located and those values. Now, the textbook does a pretty good job of explaining these types of relationships. All right? And as we work through this, I want to make sure, okay, that we understand how this works, okay? Now, I have my Karma Digital, and I've got the production volume, and this is based on the line of best fit, also known as the equation for a line, okay, where it's y equals mx plus b. And what we're doing is we're looking at the rise and the run. Okay? And again, if you had geometry or remember, or you did a little bit of linear algebra, it's pretty simple. We have this equation. To get the predicted percent, we take the product volume times B10. Let's find B10. Okay. And here it is. So we're going to take, and pardon me, I'm going to equals the production volume, okay, times B10 plus the intercept. And that'll give us the percentage. Okay. Now I'm going to scroll over here for just a minute, and you'll see this is the output from the regression analysis or linear regression in Excel. We use the regression equation. And we get this output that gives us the statistics, multiple R, R square, adjusted R square, the standard error, the observations, the regression, the residual, and the total. Residual is how much it's off. Now we have two key things here, these coefficients, the intercept, okay, and the production volume. Now, here's that cost estimate file, all right? And as I've got it noted here for you, the slope equals the variable cost, okay? And the intercept is the fixed cost. And it's the rise and the run. Now this has some other things in it, so we'll take a look at it here in just a few moments. So here we've gotten the regression line. We predicted the percent defective. It's production volume times B10 plus the intercept. Same story here. And you'll see the only thing that changes is the rows. And so we come down here, right? And we have our predicted, the prediction. So I'm going to do something here, and I'm gonna copy Carmen Digital, create a copy, and there's our copy. Okay, there's the original, here's the copy. Now we've got some output down here and over here, so I'm going to dispense with it. And we're going to start with equals the production volume, the regression line equals the production volume okay, times B, and it would be 10, 11, whatever. You'll put that product in parentheses plus the intercept. All right. Now, I'm going to use my cursor and put on here and show you, as you can see, here's the series, the defective point at 15 million, okay, and the percent defective. This is the series percent defective trend line, the second trend line. And we have some data here. The most important is this R squared. I'll zoom it up just a hair. Not too much though. R squared, as I show you here, is, and you can see these a lot better, the intercept Y, you notice it's using scientific notation, and here's R squared. R squared is important because it's correlation squared. It tells us what percent of all variation occurs at this, because of this comparison. Okay, and so as you look here, that 0.792 means that when we compare these two variables, production volume versus percent defective, that the comparison explains 79% of any variability or uncertainty, or really it tells us how accurate the comparison is. Let's just put it like that. And the larger the R squared, the better. Okay, so we look at a 0.79, and that's very, very significant. Now, look, I'm going to scroll this thing back down, okay, as you begin to see it, and then we'll do the equation here. And you can see, oh, this is not good. Let me pop this back up just a hair. There we go. There you can see the linear trend chart. Now, these are the percent defective, okay, the vertical axis values. These are levels of production, the x-axis, the independent variables. We talked about those. And then we could see, now we want to insert, and I'm going to do this. I want to do a, see, I'm going to click in the chart. I'm going to click inside this chart, and I'm going to go home. I'm going to click inside the chart, and I'm going to click design and chart element, and I want to add a legend to the right. And there we are. Now it's a lot easier to see. The blue dots are the percent defective. That's the actual. The red dots are what we predicted using the regression line. And then we see the dot is the linear regression line for the percent defective actual, and then the linear trend line for the percent defective based on our regression line, our predictions, okay? So that's what the legend is showing us there. Okay, so now I'm going to go ahead and get rid of these things here. We're in this new tab. I'm going to get rid of that. I'm just going to try to cut the whole thing, and it's gone. Okay. I'm going to come over here in the summary output, and I'm going to get rid of that so we can run it, and you can see what it looks like. And I'm going to put no border, and it'll come down here, no fill. I'm getting this ready for us to work it. Here's the residual. Here's the residual output. Here's the observation. That's each year. Here's what we predicted we would have for percent defective. Here's the residual. In other words, how far off were we? Now we'll just get rid of that because we're going to recreate that output anyway. And I'm going to get no borders. And we're just kind of stripping it of all that so we can get our new output. Okay. I'll just go ahead and get rid of all the all right. So now we're ready. And I'm going to get rid of these. So I'm going to make the predictions. Okay. And this is going to equal, and I'll start my parenthesis. And I'm going to use production volume. So I'm going to go over here to my formulas. Okay. And to the name manager. And I'm going to use in the formula production volume. Okay. And as was the case, I've got production volume. I'm going to take it times B10. And we're going to add, I'm using the line, using the formula, the intercept. Okay. Let's see why I'm getting this. Oh, I guess the name manager is not going to carry over for me here. So let's just do this. I have the production volume. Plus the intercept. Okay. And that should give me my answer here. So we'll just do this. Well, we need to run the regression first. I'm sorry. And I'm going to try it with regression here. I'll find the, I need to go over here to the data. Okay. It's not playing nice with me because I've got a solver. I don't know why I'm getting this weirdness. All right. And we need those coefficients, so we're going to need to run the regression. So I want to look over here. And it's not letting me add in the tool pack. Great. So I'm going to make sure I have the tool pack added in here. So let me come in here to the options, add-ins, and the analysis tool pack is there. So that shouldn't be a problem. Okay. So I'm going to use formulas. That's not going to play nice with me. Oh, give me a solver. Oh, there we go. Okay. There it is. Finally. And we'll want to come over here and click regression. And we'll click OK. And here we go. The input Y range is going to be the actual percent defective. And we're going to stop at, we'll go all the way down to 2010. And the X range, okay, is going to be the production volume. Should be. And I have labels. Okay. And I want in an output range. Okay. And I'll find that range over here. And let's see, I want residuals. And I want the line fit plots. And the confidence levels, yeah. And just see, and I've got the line fit plots. And I want to also add the name in here. And we've got the confidence level. So let's click OK. Okay. And it gives these figures. Let's scroll over here. We'll see our line fit plot. Now, we're going to have to take this and move it out a little bit. Okay. There's the line fit plot for 30,000. I'll move this out for a minute. Here's the production line fit plot. All right. Now, I have the linear, and these are the percent defective and the predicted percent. So I should have those over here. And I want to select the data. So I should have my predictive data. So I'm not understanding why I didn't get the output that I should have. I have the regression, okay, I've got the intercept. And so this is going to be equal. And we come down over here. Now this should be renamed. So I want to do this over. So I'm just going to simply get rid of this. I'm not satisfied with what I've got here. And so I'm going to wipe all that out. You have these days. I'll have all of this. We'll wipe it out. And go back to home, and we'll put no fill, nothing. All right. Now, let's get ready to do this. So I'm going to click Data. And I'm going to choose the regression. Okay. And the input Y range will be the, will be over here. Well, let's see. That's going to be, no, we'll leave it that. The actual percent defective. And we'll scroll on down here. Okay. And then I think what I want to do here is, I'm going to go back here for a moment. Yeah. Now I'll find my input Y range. Now let's see what I get popping it over here. And then the input X range would be the volume. And labels. Let's output range. Residuals. And label. And let's see what we get. Okay, one day. Okay, I need that. Okay, so I'm going to have to do this. And I have the input range. I have the X range. I'm sorry. Been a long day and my brain is simply not working. And I've got labels. I've got the confidence level at 95%, the output range, and let's see what we get. I'm going to put the output range over in L. All right. Now we'll click OK. And we'll overwrite what's there. Now let's scroll down here. And we've got our intercept. And I'm going to change this to production volume. In fact, I'm going to change this. I want to go into the name. I think I'm going to use the well, I don't want to do this. It's not giving me the manager. So I'm going to put production volume. Okay, one word. There we go. And then I'm going to have a name manager. I'm going to delete both of these. And I'm going to create a new one. And I'm going to call it production manager. And it will be okay. Now I'm going to edit this for a minute. And I call it production volume. Make sure it's there. Good. All right, we're good to go. Now I'm ready. And this is going to equal I'll put this in parentheses, this product, B10. I'm so sorry about this. I'm just tired. And I'm going to use in a formula a production volume. Okay. And it will be plus, and we're going to put the intercept, and bingo. There it is. There's our prediction. Now, I'm going to go to the name manager. And I'm going to delete this. Yeah. So we've got the value. And I'm going to close this off for a minute because this is not right. So I'm just going to go into the name manager, do a little bit of work here. I'm going to delete that. Okay. And I'm going to call it, I'm going to create a new one. And the name will be intercept. Okay. And I'm kind of doing this hard way. That's all right. Intercept. Pardon me, this. Okay. And now let's check. We have a production volume. And we have a value for it. So we're going to need to edit this. So let's look now. We have our values. And we're good. And just to help out a little bit, close. And I'm going to come over here and put some shading in this thing to highlight it. And let me get rid of the yellow. I don't want to do that. Let's see here. I want the font size to be automatic, and I want some shading. All righty. And make them bold. And I'll make them a little bit larger. We're just doing some formatting here. We're going to get here. And I've got the intercept. Okay. And I've got production volume. And then we have the coefficients. So let's make sure we've done this right. Go back up here to data, the formulas, and we'll go to the name manager, and we have the intercept and the production value. Close this off, and now we're ready to do our work. And so this is going to equal, and I'm going to use using a formula, the production volume, okay, that coefficient times B10, and that's the production volume. This production volume that we have, or product TO volume that I put in here, I'm about half asleep, I must be, refers to that cell with the coefficient. We take that times B10, and this is just like Y equals MX plus B, and we're going to use in the formula the intercept, and boom. There we go. Okay, I apologize about all the floundering, but you saw how we did it. We did the regression. Okay, we chose the Y values were percent defective. All right, and then the X values were the production volume. And that gave us our coefficients. Here's our output. In fact, it's probably not a bad idea to come over here and put this all in a nice shade that works for it. And then I'm going to bold all of it so I can see it. There's a multiple R, R squared, etc. We'll go ahead and make these bold, and we'll put the fill and back with all of the, and here's the coefficient, F statistics, the regression tool in Excel has a tremendous amount of value that it loads you, and probably for our purposes, not probably, but for our purposes, the key thing for us is to understand that our square value, okay, let's see if we put in a line group, okay, and this is be at various levels of production, and so we'll do the line fit plot. And we're going to size this out a little bit. And this would be, I'm going to label this volume versus volume. Okay, I know what I'll put here. I'll put production volume versus percent defective. Okay, there we go. Now I'm going to size this up some more. I've got the room to do it. I'm going to come down here, and that would be production volume. Okay. We can stretch this out to see it a little better because we're still going to work with it a little bit. And you can see we got series 1, and I'm gonna and I want to edit this. And it says to let's just the data, but I don't want to do that. We know what's predicted and we know what's the production volume. So we're going to do this now. We're also going to pull this out a bit more. Okay. Now I'm going to click on one of these and I'm going to say add trend line. And the book talks you through that. And we're going to do linear. We're going to set the intercept. We're going to display the equation on the chart, display the R, the things they talk about over there in that textbook. And we'll stretch this out just a hair. And we'll come back to it here in a minute. I want to do some more work with it. But those are the choices that we would want to make. And I don't have any effects. I'm trying to pull this over just a little bit more, but I'm not getting any cooperation. So now we get rid of this. Well, we have the linear, and there it is. It went ahead and did it for us anyway. I didn't need to turn it off or anything. So take this, I'll move it up. Here's our R squared. Over here, I'll put percent defective. Right? Now, maybe linear. Now we get rid of that. It's basically the same thing. Tighten this out a bit. Okay, so we've gotten that done. Now let's go over here and take a look at this. All right. Now all I have to do is just simply drag and drop this down, and we should be good to go. And there we go. So we've got the production volume and the intercept, and then we get the predicted percent defective. Now I want you to notice something, okay? The R squared here, we had an R squared of 82. Now earlier we had 79.79, here we have 0.82. And notice something, as we move through time at about this year, 2008, we're dead on accurate. Then we begin to understate. Okay? Now we know there is a direct relationship between these two. We have it in terms of the intercept and the production volume data. I'll make them up a little bit larger so we can see them a little better. Okay, there's the coefficients. And we can come over here and graphically we see it. We see the line of best fit or the linear trend. Okay, and away we go. Now I did a little prettying up with this. There's the multiple R, the R squared, the regression statistics. And you can see what it's telling us is we have a problem now. We've identified it. The more stuff we make, the more junk goes out the door. So we'd have to do some intervention here in terms of quality control to stop this. Because every time we send out, the more we make, the more junk we're sending. So we're going to have to find the source of our problem. We're going to have to find out. It can either be from our vendor if they send us material, DVDs, a master copy. It could be our copying process that's causing the problem. But there's no doubt that the more we make, the higher the level of defectives that we have. Okay? So this one is a little bit of a rough excursion, but we're not too bad shape here. Okay. This one's a little nicer. This is the one that I've worked on. Oh, and I had knocked this out. I'm going to close this and not save any of these changes. And I would go into the files, and I'm going to find that XLS9. Okay, there it is. This is the cost estimate fee. Let's do this. Let's see if I can find it. I may have an XLS9 key up there for you to take a look at. Well, here's Karma Digital. Okay. And we'll download this. I'll put it over here in my toolbar. Karma Digital, you could also upload it. And I, of course, you'd save it to your desktop, so I'm enable the editing. This is a nicely worked up copy. So here we are. And we had run the regression. Okay. And there's R2, and we have an R squared here of 0.79. Now I'm going over here to data analysis, and I'm going to click on regression. And see if they're not going to give us that. We'll close this off now. Now, production volume is this production volume coefficient, and there's the intercept. And it's time times B10. And you can see. Now, the chart over here is pretty. I took time to work with it and make it look nice. Here's one that's even nicer. And I have the production volume line fit plot. And you can see. You say, okay, now, we've identified the fact that the more of this stuff we make, the more junk we send out the door. What do? We're going to have to walk through a process, quality assurance process, where we're going to have to check what comes in the door to us. If these DVDs that we replicate are being sold to us, the blank ones, we're going to have to check them for defects. We're going to have to check to see if the problem lies in how we copy them, or how we store them, or how we package them. And those would be some questions that we would want to ask in terms of understanding this. Okay? So this is Karma Digital, and you are very welcome. It's over there in the files, and you're very welcome to upload it if you wish. Okay? Now, when I go back here, I'm going to close this, and I go back to the modules, and we'll close this. We'll come down here, and we'll talk about this. And we've done the OQ, so now we're working on the XLS9. This is the copy of XLS9, the cost estimate. This is a key, and I'm going to open it up. So you have 3 files that you could use for XLS9. The example, this file, or Karma Digital. And I think just to keep everybody from getting knock-kneed, I'm going to go ahead and click Add, and I'm going to add a file, and I'm going to find Karma Digital. There it is. I'm going to add it. Okay. And Karma Digital should be added here. There it is. And I'm just going to move it up here. Okay. So for XLS9, you can upload the example. You can upload this copy of the cost estimate, or you could do Karma Digital. Let's look at this copy of XLS cost estimate, the key, and it coincides with the textbook over there. It coincides with chapter 53. And you'll see here, and I apologize about the kind of whiffing around with it. That's just sometimes how I work. We have independent variables, we have a dependent variable, and you can see the difference between the two of them. And the authors do a good job of explaining that. Then there, of course, this should look familiar, the format, the trend line. And then we see the file. This is 53-2, the plant operating data. Okay? So I'm going to come back over here. And, well, I thought I had it opened up. Yeah, here's the copy of cost estimate key. I think I have it on my desktop, so I'll simplify this. Yes, come in.
Hello.
Hi.
How are you, Dr. Norman?
Pretty good. Okay, and we'll look at this copy, and it has the cost estimates. This is a copy of it, right? Now, here, it's a little more extensive. You could use this. You could also use the key. It's over there since, and let me diminish this and just make absolutely certain you know what you can turn in for XLS9. You can turn in this, or the example, or Karma Digital. Both Karma Digital and XLS9, this is one's from the book. This is one of my old case files. So you can turn either one in. I want to talk about this approach or file that's used there in chapter 53 of the text. Now let's talk about this for a minute. We have a data table here. We have the month, the units produced, the monthly plant cost. We have the sum of the errors predicted in terms of the cost. And then we have the error. Okay. And that's going to be the sum of the errors predicted is 64.2687. Now, if you look, okay, that's the slope. And that's times C3, which is the units produced, plus this 37,894, that's the intercept. So the first thing we're going to do, all right, is we want to use our name manager. Okay? And I'm going to click Formula, and I'm going to click Data Manager. And it says I have an intercept and a slope. Okay? So I want to make sure I get all the names I want. So I've got the slope. Okay? And I have the intercept. Now, I'm going to click in here. And that's going to be this first cell. This is going to be the slope. Okay? The slope is, it's headed upwards. Then remember, we have the rise and the run. The intercept, the slope is the variable cost, as I note here, because it's the rise and the run. The intercept is the fixed cost, it's headed upwards. So the slope is, we have the slope, okay, times C3 plus, and that 37,894, that's the intercept. So I'm going to use the name manager to bail me out of this. So I'm going to come in here. And instead of all of this gobbledygook that makes no sense, I'm going to use the name manager. I'm going to use a formula. Come here. And this will equal, and it's going to be the slope, okay, the rise and the run, and that's going to be times our units produced, which is C3. And just to be on the safe side, I'm going to put a parenthesis here around this product, and then I'm going to add the intercept. And I'll use intercept, boom, and there we are. And I can carry it all the way on down through to get my sum of my errors of the predicted cost. Okay, now the error. we want to see how much error we have in our prediction, in our predicted costs. And remember, the intercept, that is the linear trend, is the fixed cost. It stays the same. Okay, it's the rise and the run, the slope, that's the variable cost. Okay, and we've got this estimating. Let's go down here and take a look at this for a minute, and you could see the monthly plant costs, how it's charting, and how it's headed upwards. Now over here we have the monthly plant costs with linear trend, and we have the R equation. And that R explains the amount of variability. Okay. Now, this is going to be D3 minus E3. So we're going to take the monthly plant, we're in this cell F3. You can see now why I want to do a special broadcast of this, because I want to make sure you have the time to look at it. I'm going to take D3 minus E3. I'm going to take the monthly plant costs and subtract from it the predicted cost, so I get an idea of how much error I have. And you'll notice I've got about a $4,200 error. Let's look at the next one. Notice what happens here. The error is 3,000, a negative 3,000. So you can see these errors that we've got built in with these predictions. Now, again, once I've got this linear trend, all right, and I've shown the data, then the question becomes, all right, what would be, for example, the R squared, and that's the regression squared, and R squared tells us how much variation is explained by this comparison. And what it means is I'm looking at, I'm seeing these squares, how closely, let me go over here and do the annotator. Okay. How closely do these fit? I don't like that. I'm going to take the spotlight off. I'm going to draw. Now let's see what I can do. Yeah, this will work. How closely do they fit? Notice, and then you've got some outliers here. And I'll just simply erase that. Okay. No great shakes, but we got it done. And so now we're able to say, okay, how closely can we predict our costs? Now, I'm one of these that I like to see and this helps me understand that this is high, this is below, this is high, this is below, 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 and then watch what happens. So you can see those variations in the predicted costs. So I'm going to click on here and I'm going to select data, and I'm going to get, I'm going to add query, and I'm going to add one, and I'm going to call it predicted cost. the series X values. And yes, it would be these. And the Y values. Let's see what kind of gobbledygook I did there. No, I messed that up. I don't really need the predicted costs in here. I can see these up here. What's more important for me is to come over to the output and notice this is a prediction. And here we are. This would be year 16. Okay? And we're predicting oh, just come on down here. And then we can do the error. Well, that's not accurate because I don't have my monthly plant costs. What I could do would be to use the predicted cost from the prior year, and I'm going to do that as an actual figure. I'm going to give it a proxy there. Okay. And now I can do, I note this is simply a proxy from the prior year. So we try to see the extent to which these two things flow together. Okay. Well, I've been on here quite a while, okay, and I've had to kind of rummage through my brain to run these. But this is XLS9 we've looked at in the classes today, which I didn't record those lectures in class. I'm just recording this. We talked about the XY paradigm where we compare things when we assume that they have a linear relationship. And here we've done, I showed you in the Karma Digital where we could predict the defectives based on volume. It's the same story here. And we can also look at the error. Now, the sum of the errors is up here. And that gives us a sense of how far everything is off. I would probably do this. I like a thing called the coefficient of variation. So I'm going to put COV. And I'm going to look at these errors, and first of all, I'm going to start with their average. And then we'll be through doing some statistical hijinks here. And I'm going to get these errors. Here's the average. Now I'm going to get the standard deviation. Okay. And I'm going to assume this is standard deviation of a population. And I'll get the numbers. There's a whole lot of theoretical mumbo jumbo about which one to use. Now I'm ready to do the coefficient of variation. Okay. And the coefficient of variation should equal the mean or the average over the standard deviation. Let's just check to see if I'm right or my brain as fried as it is wrong. So I'm just going here for this switch, quick search. Okay. And the standard ratio of the standard deviation of the mean. Okay, there we go. So we're good. So this will equal average divided by, pardon me, it's going to equal, whoops, I'm wrong here. It's going to equal the standard deviation divided by the average. And only can you get this, the coefficient of variation. This is going to equal standard deviation divided by the average. And this is not going to look good. I probably want to do the standard deviation. I probably want to get the average. Get the average. I'm probably going to get the standard deviation for the sample. So I'm going to see what this does. And it's going to be I had some of the errors predicted, and I had the standard error. And this should be yeah, we got I9 over I8. That just looks funny to me. Looks strange. But that's pretty much with linear regression. We talked about the conceptual foundations of it and the practical applications of it out in business. And then we've looked at Karma Digital. We used the regression line to predict. And we've done the same thing here. Okay. Using the prediction, using the slope plus the intercept. That is that model of the line. Okay, folks, that'll do it. I'll post this. I'll stop the share here, and I'll produce this, get it processed, and then post it in 1123 A and B. I'm sorry, my brain is dead today. So I'll stop the share.